Hello and welcome to this video. In this video, we are going to solve Concurrent Task Scheduler LLD problem. This was asked in Amazon, Oracle and DE Show. So now let's go to the problem statement, what was asked or what can be asked if you face this problem in your next interview. So we need to implement a system that schedules and executes tasks across a distributed set of worker nodes. The system should dynamically manage the load by assigning the tasks based on the worker availability. So these are the certain requirements that we need to design while solving this problem. Worker management, ability to add or remove worker nodes from the pool, task life cycle, support task status such as pending, running, completed or failed. What this mean that our system should have the task statuses, should support these task statuses which are mentioned here. Load balancing, distribute tasks such as worker nodes are not overwhelmed while others are idle. We will talk about these when we will try to understand this question in detail. Concurrency, that scheduler must handle multiple tasks being submitted simultaneously. This means that our system should able to handle the multiple tasks should be submitted at the same time and it should not fail. Status tracking, provide an interface to query the status of any task or worker node. This means we should provide a functionality where we can check any task status, like what is the current status of the task that we want to check, whether it is in pending state, running state or completed or failed state, right? There can be bonus requirements also where we need to implement retry mechanism where automatically retry failed tasks. So there might be a possibility that a task is submitted in our system, but due to some reason it failed. In that case, in retry mechanism, what we can do, we should be retrying the same task or resubmitting the same task again up to a maximum number of attempts. But this is a bonus requirement. It is not necessary to solve first. First, we need to solve the base requirements before moving to the bonus requirements. Now let's check what are the exact functional requirements. The system should schedule one-time tasks to run at a specific future time. The system should schedule recurring tasks to run repeatedly at a fixed interval. What does recurring task means? Let's say we need to send notification or any email every day to a particular user. So it has like 24 hours time and it should go out at 9 a.m. in the morning, right? That is the what we should our system should have recurring task functionality. The system should execute tasks concurrently using configurable number of worker threads. So how we are going to implement concurrency? That our system should have a way to configure the worker threads. The system should allow cancelling a scheduled task before executing it. So this is one more requirement that we should provide a functionality where cancel a task, right? The system should track status through its life cycle. These are the things we need to see before solving it. So now let's understand what we need to design in this task executor. Okay. So if we see, let's say we will have a certain number of tasks. Let's say we have task T1 which we need to implement as at t is equals to 5 seconds. What t is equals to 5 seconds means, let's say current time is 9 a.m. and we need to execute task T1 at 9:05 seconds, correct? This is what we need to do for task T1. Then we will submit one more task T2. This we need to execute at time 10 seconds. Then we will have task T3, which we need to execute at time 0 second. Then we need to execute, this is going to be a recurring task. Recurring task, and at t is equals to 3 second. So it will be executed at 3 second again, 6 second again, and 9, and so on. Then we will have task T4, which needs to be executed at t is equals to 5 second again. I hope you will able to understand how should our task scheduler should execute task. So now let's see. Let me create a, let me just reduce this. Just let me remove it and let me rewrite it. Let me create a scale for t is equals to, and here we have 2, 4, 6, 8, 10, 12. Let's say t1 we need to have at 3 second, t2 5 second, t3 3 second reoccur, t4 5 second. Okay, so now what we need to do is t1 should execute at this point of time, t1, t2 should execute at here, and t3 should reoccur after 3 seconds. So t3 we can say will be executed here, then t3 will be executed here, then or t3 will get executed here, t3 will get executed here, and t3 will get executed here, and so on. Then we will have t4. t4 will get executed at 5th second, right? So if you see here, this is the time scale, and at one particular point of time we are executing just one task. But if you see at time is equals to 3 second, if you see this part and if you see this part, at the time frame t is equals to 3 second and t is equals to 5 second, we need to execute t1 and t3, t2 and t5 at t is equals to 5 second. So now we need to execute these two tasks at the same interval of time. So now how our threads or worker pool threads, right? Let's say this is worker pool thread. So here we will have w1 worker 1, w2, w3, w4, w5. So at 0 it will pick t3, right? And let's say it will get executed within that 7 second, then it will just complete it, and now it is again empty, right? Now at t is equals to 2 all are empty, t is equals to 3, worker 1 will again pick up, worker 1 will pick up t1, right? Worker 1 will pick up t1, but now worker 1 cannot pick up t3, so worker 2 will pick up t3, right? Now let's say these two threads will take around 3 seconds to execute t1 and t3. Then now t is equals to 5, 3 seconds will get completed till here. right? So now where T2 and T5 will go? At that point of time, worker 3 should acquire T3 and worker 4 will acquire T5. So this is the consideration we need to take while designing our task task scheduler, right? That even though we are executing one task with one worker, it can take some time to execute those tasks. Within that time, if new task comes at that particular point of time, it should not wait. Our worker pool should pick up those tasks and start executing the new task, so that by the time t is equals to 9, all the workers will be free, and it will now w1 will again pick up t3 and execute it, right? These are the things we need to keep in mind while designing our system. So now let's start thinking about the entity classes. So first thing, we need to find what are the entities that we can create. Let's say here it is clearly mentioned we need to have task lifecycle. So we can have one enum with all these values, right? Then we have worker management. We need to distribute task to workers, right? So here task is one entity which needs to be executed. So task is going to be one entity for sure. The scheduler, here if you see the scheduler, that means there should be some scheduler class, scheduler service, or some kind of class that we should provide which will schedule our tasks, right? So we have identified, if you see, we have identified task lifecycle, scheduler, status tracking will be handled with task status. Then we will have the scheduled task. Now this task can be executed, but we there can be different types of task, right? Different types, but every task needs to be scheduled. So we can create a scheduled task entity which will have these different types of task, right? Which can hold all these task status, and scheduler will itself has worker inside it. We can create one more class if we want, the worker class. Let's see. Then if you see, we need to have one-time task, recurring task. So that means when we have task, we need to have something so that we can relate these different types of tasks, like one-time task, recurring task. How we will define that which task is one time, which task is recurring task. So we need to have some strategy for all these tasks, right? So this can be one time strategy, one time scheduling strategy, recurring scheduling strategy, right? Those things we can have. So let's see. That's what we talk. Let's say we will have one interface which has one name and execute method that needs to be executed. Then we can have different types of task, like email notification task, data backup task that needs to be scheduled at particular point of time, or this we can say recurring. We need to send some sort of email every day, or some after some time, let's say after 2 hours. Data backup task needs to be performed at a particular interval of time, one time, right? Then we have created that we need to create a scheduled task class. right, where we will have this task as defined. It will have its own ID. Task status, we need to have task status as enum, which will have all these statuses: completed, running, failed, pending, cancelled. Cancelled we have added because we need one functionality where we should able to cancel the current task, and that task, if it is scheduled at a particular point of time, let's say if it is scheduled at t is equals to 10, and let's say we are at t is equals to 5, right? At that point of time, if we want to change the status of task from scheduled from pending to cancel, because if it is running, then at this point of time we can change it, right, from pending to cancel. But if someone says that at t is equals to 11, can we cancel it? Because at t is equals to 10, its status will start be running. So there are going to be certain conditions in which we can cancel the task, not every time. Let's say t is equals to 15. We cannot cancel task t1, right? Because this started executing at t is equals to 10, and it has completed its execution at t is equals to 11, 12, or any time. So at t is equals to 15, we will not able to cancel this task, right? Those things also we need to keep in mind. So scheduled task will have one more thing, and most important thing: last execution time and next execution time. Let's say in case of one time, we will have last execution time one value, but in case of recurring, we will have we will be changing this value every time, updating, right? We need to update this value again, and last value we should be putting it here, like let's say t is equals to 6 is going to be current value, and let's say after so if the recurring time is 3 seconds, then here we should have 3 seconds. Then task strategy, this is also important. This we will talk about how we will define this. Sequence number, we will see. So this scheduled task, I will come to it, why we need a sequence number. And this scheduled task needs one more important thing: it needs to comparison. It needs to be compared. So when I say comparison, what does it mean? Let's say we are in our system, we are putting task t1 2 second, t2 5 second, t3 3 second, right? And current time is t is equals to 0 second current. So how do our system knows that first we need to pick up t1 task, not, and first is this one, and second place it should pick up t3 task. So we need some kind of comparison, right? We need some kind of comparison, we need some kind of queue to store our task, right? This is the order. First this should execute, then this should execute, and then this should execute. So for this comparison, we should be implementing this compareTo method, right? And we will see why we would need sequence number, because we are providing time here. Let's say we will have t4 at again 5 seconds. So now how we will decide that at the same time, if multiple workers are present and all are busy, let's say we have two workers, we starting with, let's say we are just starting with one worker, W1. Okay. So how we will decide that first which should go, either T2 or T4. So we cannot we cannot pick anyone randomly, right? Either we need to have some priority. So with this sequence number, we can give priority which was registered first, right? So T2 was registered first, so we will give T2 the first priority to get executed. But we will not have this condition many times because we will have many workers which can take up the task. Okay, so these are the things, these are the basic entities. Now we will have the repository layer or schedule strategy. So in schedule strategy, we will have one method, get next execution time, where we will be passing last execution time. So in case of one time strategy, this will be null, or in case of recurring strategy, instead of last execution time, we will be passing duration, that after which time, or we can say instead of last execution time, we can just pass time, right? So in case of one time scheduling strategy, this can be the time that we can pass here, let's say 5 seconds, right? 5 seconds. And in case of this can be a duration, of 3 seconds. So after 3 seconds, it should re-execute that task, right? Now we need to find the status of the any task, right? So we need to maintain a task repository where we can save each task, we can find it by its ID, or we need to find status of that task. So we can also include one more methods if there is further requirement. That's why we need to have task repository. Then we will have task scheduler service. This we can say a facade class of this system. Here we are using the task repository, executor, let's say these workers will be thread pool executor. We need to have one more functionality here, that we need to update this, right, workers. So we will have some these two methods like add worker and remove worker. Let's say we will have initialize method. We have started with 5 workers. We added 2 workers, so it will become 7. We remove 2, so it will become 5 again, or if we again remove 2, so it will become 3, right? So as I already told initially, that we need to use a queue so that we can do the comparison and pick up the our scheduler service pick up the task which needs to be executed first. So in this scenario, for task scheduler service, task scheduler, delay queue will be the best fit data structure, best fit queue that we can use, which will wait for the time and also available, which will not block the whole queue, but will only pull out the task when the delay time of that particular task is over. We will see how we will implement how we can implement a delay queue also, and how it is best fit for this case. Otherwise, if we are not going to use delay queue, then we can use priority queue, and we need to override the compare method. We can use priority blocking queue as well. These sort of things we can use. So this is very important for this task scheduler. This queue implementation and queue uses itself make this problem the hard level, because many people will not able to select the correct data structure here, and even if they select the correct data structure, they will not able to implement it correctly. That is very important for this problem statement, that how we are implementing the correct strategy to take out the task whenever the time is due. So these are the methods. We need to again add one more method, cancel task, where we can set the status of the task cancel. Then we will have demo class in our code, which will tell us how we are going to solve this, how we are going to use all these classes and see our code running. So let's see UML diagram before implementing the solution. So as we discussed, here we will have task, interface, execute and getName method. So it will have scheduled task and task status enum, where you can see all the, so every task, when we create a task, it will always has start, scheduled or pending, what we can say. Whenever we create a start, it is not started, right? It is not in running state or complete state. It should be starting with scheduled status. So in scheduled task, we will have task ID, strategy. We have one interface, strategy, schedule strategy, which has this method get next execution time, where we are passing the execution time, and the implementing classes of those are recurring schedule strategy, which will have an interval, and the which will have a duration after which we need to execute the same task again and again. One time schedule strategy will have the execution time, like at what time we need to schedule it, right? Then we have the next execution time and last execution time, and the status, right? Here this scheduled task, if you see here, there are two methods, getDelay and compareTo. So these two methods we need because we are going delay queue in our implementation. So we need to implement delayed interface. For that implementation, we need to implement these two methods. So these are just getDelay method. We will see how we will use it. Okay. Then we have repository, task repository, where we can save any task that is getting created inside our task scheduler system, and we can find any task with the given ID. So the in-memory task repository class, we have also implemented that interface, and then this is our main facade class, task scheduler service, where we have the delay queue, task repository, sequence counter, workers, where we can dynamically add or subtract the existing workers while running, when the even task scheduler service is running, thread pool executor, dispatcher thread, and there is one flag which we have just used running, so that we can identify if our task scheduler service is running or not. Then we have certain methods here. Most important is here schedule, which will be helpful for scheduling the task. Then we have cancel task. We need to initialize our task scheduler. This add worker and remove worker are part of those methods which we need to implement as part of the requirement. Then we have shutdown method also. When we will close this scheduler service, at that point of time we need to uh, close all the threads and dispatch loop method, which is the dispatcher thread which will be executing the dispatcher thread. Then we have execute method also, which is executing the scheduled task inside the dispatch loop. Okay, so now let's see the coding implementation. We have gone the overview of UML diagram. So here if you see task class, right, we have the execute method. Then let's see the email notification task. Here we are overriding the, as we are implementing the task class, we are overriding the execute method. Like when this task is getting executed, right, at that point of time, what should happen with this particular task? Those things are defined here, and we have just given its default name. So, and these are the things we can have in this. Then we have data backup task. Here we have source and destination. In case of execution, what will happen? So we are just printing the values, uh, but in actual scenario, in actual use case, there can be multiple things that can happen in real scenarios, but currently we are printing it. So this is task enum class, where we have scheduled, running, completed, cancelled, or error state. Okay, so we have completed all things apart from scheduled task class. So this is implementing the delete methods. So if we go to when I have said here that in schedule task we need to have some kind of comparison, but if you see in code here that I have implemented the delete interface. So if you go through it, if you see here, it is itself extending the comparable class. So it has this method, right? And if you open this comparable, it has the compareTo method. So it is extending the compareTo method, and along with that it has getDelay method. So this method returns the remaining delay associated with the object in the given time unit. So what does this mean? Let's say it is saying that it returns the remaining delay associated with the object in the given time unit, right? So let's say we have t is equals to 5 seconds. T1 needs to be executed at t is equals to, but the current time equals to 3 seconds, right? So get delay method, if we pass t1 time 5, it will return at t is equals to 3 seconds. What is the remaining time? So 5 minus 3, it should return us 2 seconds. Okay, so how it will do? This is the responsibility of this get delay method. Okay, now let's go back to code. So now if you see what I said, that when we are scheduling a task, every task should be in schedule state whenever we are starting a task, right? So if you see here, we have overridden the get delay method. If next execution time is null, then return 0. Here we are calculating the millis. We are calculating with the current time and the next execution time, 2 millis. And then we are converting it if it is greater than 0, like which is greater than 0. Millis is the current time, or 0. If 0 is greater, then we will return 0. Okay. So this delay get delay response is used in the compareTo method. See, it is using the delayed other. So here we have some checks, that is the next execution time, and both the next execution time is null. Then we need to compare with the sequence number. So as I said previously, right, we have sequence number. Let's say these are used in case of tie. If there are two tasks T1 and T2 have same time, then we need something else to compare, right? So this sequence number will be like that if we are submitting task T1 at time 3 second, and let's say we submitted task T2 at time 3.1 second. So sequence number, it will get sequence number, let's say 1 2 3. So it will get sequence number 1 to 4, right? So with this sequence number variable we can differentiate with it between, we can compare easily, right? So instead of having sequence number, your interviewer can ask you one more updation or one more requirement, that you need to decide, you need to design your task scheduler based on the task priority. What it can be? It can be like high, medium, low. Okay, so based on that, like both needs to be executed at 5 second, executed at 5 second, but it can have high priority, it can have low priority. So which needs to be picked up first? So now you will question me, hey Naman, we have uh, designed our system in such a way that we have multiple workers, right? W1, W2, W3, W4. Even we have two tasks with 5 second, or t is equals to 5 second to t1. But let's say we have tens of tasks with t is equals to 5 second, t4 is equals to 5 second. Let's say you will increase it to w5 so that it can accommodate t5 is equals to 5 second, right? But now what will happen to t6, t7, t8? All all are also needs to be executed at same time. Now if we have a limited number of workers, these tasks needs to wait, right? So in this case we need to have some sequence number, right? So whichever task has come first, let's say we are going with order, that's why we will give priority to these, and let's say this will take just 0.1 seconds to execute. So at t is equals to 5.1 second, t6 will be picked up, t7 will be picked up if those two tasks are completed in 0.1 second, right? So these are the things. So your interviewer can ask you that if we want to prioritize it, then let's say if t8 comes and it has the high priority, so instead of t4 which has low priority, we should pick up t8 instead of waiting in queue, right? These conditions we need to explain to the interviewer how we can do that. Okay, so that is what I am currently solving it with sequence number, but it can be extended. Here we, what we can do is we can create one more class uh, enum with task priority with high level, high, medium, low, and we can have task priority, and here we can change our logic, compare to logic. Here we are comparing with the sequence number, instead of that we can compare with the priority of the current task, right? So we have these here we are comparing with sequence number if the execution time comparison is not present. Okay, otherwise in the end we are just comparing with the get delay. See, we are using the get delay method to between comparing the two tasks. Okay, so this is about that. Task repository we have already gone through, and schedule strategy. If we see now one time strategy, so it has local date time, last execution time. It can be just time, we can have time. It can be of duration or one time execution time. So in one time schedule strategy, it is last execution time or time, whatever we can say. So here we are providing the execution time. So whenever we will create an object of one time schedule strategy, we need to provide execution time while creating its object, and that time will get returned. Okay, that strategy will be, if you see here in schedule task we have strategy. Here we are checking, we are assigning the strategy, and here we are updating the next execution time. So if you go through it, it is doing the this method called get next execution time, and here we will get next time, and next execution time will be set on this call, whatever we are going to get back. So in case of one time schedule strategy, we will going to get the execution time that we are going to set when we are creating object of one time schedule strategy. Okay, similarly we have recurring schedule strategy. So in this recurring schedule strategy we have interval. Okay, in this interval uh, we can pass duration when we are going to create recurring schedule object, and that on that basis we will be passing that. So one more important thing here is in case of recurring event, recurring task, we need to change status of the recurring task every time from schedule to running, schedule to running. Let me explain you. If you see, this is the task lifecycle, right? Schedule, running, completed. This is very basic, right? This is for one time. This seems pretty fine, right? But in case of recurring task, once it is scheduled and once it got ran, it needs to be scheduled, right? And it needs to be again run, then it needs to be again scheduled, right? It should be go in loop. If there is no stop time, it should not go to the completed state. It should always loop between these two states. So that also we need to take care while designing, while implementing it. So this will always give the next execution time based on this interval. Okay, so if you see, we are adding the interval here every time when it is asking in the base time. Okay, now we have our main facade class, task scheduler service, and this has the core logic of this system. So we are just taking minimum worker, that at any point of time our service should not have less than one worker. Here we have created the single instance, like we have created the, we have made the method private. So we whenever we are going to call its method, or whenever we want an object, we will get the same object of task scheduler service, right? Singleton object implementation. Then we have worker sequence that we will use here. What we have talked about, why we have uses implemented delay inside the schedule task, because we are going to use delay queue of type scheduled task. Okay, then we have task repository for having the all the task inside our system. Then we have created sequence counter. We have thread pool, executor, workers, dispatcher thread, and flag for running. Okay, so the first and most important method, initialize method. So if you see worker count, where we need to pass the worker count initially, let's say 5. So 5, we cannot pass negative value or 0 value. This is that check. And if it is running, if it is already running, then we should not be initializing it, right? Initially it should be false. Then we will enable that flag. We will mark that flag true. Then we will create the worker pool. Then we will create the dispatcher thread, and we will set daemon true and start the thread. So in create worker pool, if you go, what we are doing is we are just creating thread pool executor. Inside that we are passing the worker count. This is the maximum number of workers, minimum number of workers. We are passing core pool size, maximum pool size, keep alive time, timeout in seconds, and we are passing the blocking queue. Okay, then here we are setting allow core thread timeout is equals to true. Means after 60 seconds, let's say if one worker thread is alive, is idle for 60 seconds, then it will be, initially we have 5 workers. If one worker is idle for some time, then it will be terminated and we will have 4 workers. But how this will work, if we require 5 workers, then it will our execute method for this thread executor will have that worker running. So it will help us manage the memory and space. Any ideal, let's say if the number of threads are much more than that single number, right? If 100 threads, then we should be terminating the ideal threads and only creating them when we need them. That is the main use of this allow core thread timeout. Okay, now let's see, here we have a dispatch loop that we need to see what it is doing. So this method will run infinitely while running. If this is true, then it will run. Then here what it is doing is, I will come to this part. Here it is trying to take the existing task, whatever task is coming. If it is cancelled, then it should not, we do not need to execute it, right? So here we have thread executor pool that we have got in workers. Inside that we are submitting task if it is available. If we have got this task, scheduled task, then we should be executing it, because this will only give when it's time. It's time to execute. This will return the task. Okay, so at the same time we will submit the task, execute the task to our thread pool. So what we are going to do here, if you see, we have created this method try mark running. If the status is not scheduled, then because every task initially is needs to be scheduled, right? Then we should return false, right? Then we will be marking it as running and then returning true. So it will return true and it will not go inside it. Then we will save the task in the repository, because we need that task from this repository if someone asks what is the current status of the task. That's why we are saving this task in the repository. Then we will do the get task method called execute. After executing it, we will update last execution time. This is very important for the recurring task, or for our analysis later we want to do, like when is the last time this task was executed, right? Then we will have handle success and handle failure method I have created, where if it is completed successfully, we need to change the status, right? and update next execution time. So there are two conditions here. If task has more execution, we can check it. If next execution is not null, that means it has more execution. Then in that case, we need to mark it as scheduled, right? And save the status of the task. And then again, we need to add it in the queue, because after executing it, our queue will pull out each task every time, and then we need to submit it. But if it is a recurring task, based on this condition, we need to again add it in the delay queue. If it is not a recurring task, it is just a scheduled task, then we need to mark the status of the status completed and just update the task in the task repository. Similarly, if we have some failure, let's say we got some exception, then we just handle it and mark the status as error, and we will update the task repository. So we have updated the, now we have seen execute method, we have seen the dispatch loop method which will run continuously. So now how I need to explain how queue is working. Let's say we have this queue, okay. So t is equals to 3 second, t1, t2, t is equals to 5 second, t3, t is equals to 6 second. This is recurring, right? So when we call offer method, and if the time is t3, time is t is equals to 3 second, it will pull out this task t1. Now this task will go away from here and it will get executed. Now this is empty, right? Again at t equal to 5, we will call task delay queue dot offer method, and this will pull out the t2 and we will execute it, okay. So now this is also empty. At t is equals to 6, right, we will pull out t3 and execute it. But because this is recurring task, right, after execution we again need, at, let's say if recurring time duration is 3 seconds, then we again need it at t is equals to 9 seconds, right? So we again need to put this t3 inside it, and with t is equals to 9 seconds, right? This we need to put inside it. Sorry, I made a mistake. This is not a offer method which will pull out the task inside delay queue. It is the take method. Offer method is for adding it to the queue. So here we will call offer, okay. This, if you see, this is what we are going to do: execute, update execution list, handle success. In that case we are doing offer when we need to re-add that particular task in the delay queue. So now we have gone through most of the things: initialize, get worker count, get active worker count, shutdown we have implemented. We need to intercept the dispatcher thread because it is running in infinite loop. We need to do workers dot shutdown, thread pool executor dot shutdown method. Those things we need to do, and we have gone through all the methods here. Yeah, these two methods are pending where we need to add workers in our worker pool. So we need to, how we are checking it, we need to check current size of the pool and the count. Here we need to add it. Then we need to call this resize worker pool. So here we will check if new size is greater than the core pool size, then we need to change the maximum pool size and set core pool size. If it is not, then we need to just set core pool size and we can reset the set maximum pool size if it is less than the core pool size, right? So this is what we have implemented. Now let's move towards the demo. Okay, so if you see, what we have done here is we have we have taken the instance of the task scheduler service where we got the singleton method. Here we have initialized with worker count 3. Then we have one-time task with one-time strategy. So we have print message task where we are just printing it inside the execute method. Okay, and we have recurring task with, we have just named it recurring task, but it will become recurring task with the recurring strategy. Then we have backup task with data backup task with backup strategy. Backup strategy is nothing but just one-time schedule strategy. Then we have email task where we are implementing the email notification task. We have email strategy, one-time schedule strategy, or we can use recurring schedule strategy as well. Now we are scheduling tasks, so we are just calling the schedule method, one-time task, one-time strategy. We have schedule method, so let's see what we are doing in schedule. You see, we are just creating the schedule task as we are just passing the normal task inside it with the strategy, and here our sequence counter is incrementing each time as it is atomic, so it will work correctly in concurrent environment as well. Then we are adding it in task repository, and then we are adding it in the delay queue, and then we are returning the ID if we want to print it, right? So we have scheduled it. Then we have some thread sleep. Then we will do some, and we are printing it here. Then we are just testing our functionality of adding worker and removing worker, how it is behaving. And then we have this one more functionality that we need to implement, get task status, right? What is the current status? Then we are just shutting down. Now let's run this code and see what we are getting. So if you see, we are scheduling task. We started with 3 worker threads. So if you see, we executed. This is one time. This is recurring. This is sending to gmail.com. This is email notification task. So this, after completing this got printed. Then we have you scheduled report is ready. Subject body got printed, and this is sent successfully. So this is just one task, and these are separate tasks. So now this recurring task, if you see, it got printed after again a particular point of time. Then we change the worker pool size. After some time our data backup task got executed because this was scheduled for a little bit later. You see, it was scheduled for 5 at t is equals to 5 seconds. Then we remove the pool size. Then our recurring task is still running. One time task status is completed. Then we just shut down the scheduler. So if we have not shut down the scheduler, it has ran, this recurring task has ran for infinite, like this task should run infinitely, right? So I think that's all about the LLD implementation of concurrent task scheduler. I hope you like this video. Please share it with your friends and please subscribe to my channel. Thanks for watching.